today for Organic Friday, we are going to talk about carboxylic acids. So the goal is for you to recognize the functional group for carboxylic acid and to be able to name simple carboxylic acids. So the basic functional group for carboxylic acids, you have some alkyl group, we're just calling it R to be generic, followed by COOH. But what I mean by the COOH is that we have a carbon double bonded to an oxygen and then an OH group. All right, this is the COOH. COOH. And that's what we mean. This is our basic structure for a carboxylic acid. So I have this big giant molecule down here, and it's got two carboxylic acid groups in it. They're very common biologically. So can you guys recognize that basic structure? Great. Shows up a lot. And there are reactions that carboxylic acids do. We'll talk about that actually next week when we start talking about esters, but these are an important group functionally. In terms of making carboxylic acids, they tend to be made from primary alcohols. Right? So an alcohol where the OH group is on the end of the chain is a primary alcohol. Right? And so if you oxidize these, they can form carboxylic acid. If you look at that group, though, we have polar bonds between the carbons and the oxygens. Right? And so these tend to be polar carboxylic acid groups. They've got a hydrogen connected to an oxygen, so we can form hydrogen bonds. In fact, sometimes carboxylic acids will dimerize. They'll form hydrogen bonds with each other and form dimers. But they can hydrogen bond. The other thing I wanted to point out about carboxylic acid is that if we lose a hydrogen and form the anion, we actually have resonance structures. And so these tend to be a little more reactive because you can form two resonance structures, which give them stability when they lose that hydrogen. So we can talk about sort of a 1.5 bond order all the way around of this group. So I just wanted to point that out to you. Now it's actually very, very easy to name carboxylic acid when it's based on a simple alkane chain for R. Basically what you do is you identify the alkane chain, right, the longest continuous route, drop the E, and put oic acid on the end. So easy. Although they do have common names as well. All right, so this is the structure of vinegar. All right, and its common name is acetic acid, but we want to give it its official name. Right? How many carbons are here? Look again. This is actually a carbon right here. Right? I don't know if you guys remember that naming system or that drawing system where we don't always show the carbons. So this has actually got 2 carbons in it. Right? There's a total of 2 carbons in the molecule. What's the prefix for alkane groups with 2 carbons? S, what we call ethane, right? So the name of this systematically is ethanoic acid. Ethanoic acid. Right? It rolls off the tongue. Ethanoic acid. Right? But if you want to call it acetic acid, that's okay too. But its systematic name is ethanoic acid. Are we good? Pretty easy. Let's go on and just do a couple of examples so that you're familiar with it. Right. Oh, the next one, this is formic acid. Now, formic acid was actually isolated from ants. Like you grind up dead ants or live ants, and you can get formic acid. How many carbons are in formic acid? 1. What's the name of a 1-carbon alkane? Methane. So this is methanoic acid. All right, how many carbons are in this? 3. All right. What's the name of an alkane with 3 carbons? Propane. All right. There are 3 carbons, so this is propanoic acid. All right. How many carbons are down here? This is butyric acid, is its common name. Terrible. Butyric acid. How many carbons? 4. So what is the proper name of this? Butanoic acid. Excellent. Do you guys feel comfortable with recognizing carboxylic acids and naming simple ones? Then we are good to go.